first. So is this slide visible to you guys? Can you see the slide? So is it visible? Hello.
Yes, sir.
Yes, sir.
So in our previous class, we ended up our class here. That means we show you guys some of the equation, or equation of motion when the acceleration is constant. Now, today, can any of you tell me an example of constant acceleration in your real life? Any acceleration that is constant and occur naturally. Constant acceleration. Can you give me an example of constant acceleration that occur naturally? That is what? Please tell me. That is G. G is acceleration due to gravity, and it is constant at a particular place. It is constant, right? 9.8 meter per second square. So what is that? If you fall an object freely, then you know, like let's say you have a ball in your hand, and if you just drop it, or if you just drop it, then the object will fall downwards at a constant acceleration of 9.8 meter per second square. And these kind of objects are called free fall acceleration. This kind of object are free falling object, and the acceleration is called free fall acceleration. Free fall acceleration is basically G, which is equal to 9.8 meter per second square. And for free falling object, and if the object has free fall acceleration, in that case the equations are like v equal to u plus at, or v square plus u square plus 2as, or s equal to ut plus 1/2 at square can be modified. And in that case, actually, we can write a new set of equation. In that case, we just have to replace a by g, like v equal to sorry, my PowerPoint is creating problem. So, right. Can you see the slide now?
Yes, sir.
Okay. So in this case, we can say like we just have to replace a by g, and the equation will be v equal to u plus gt, or v square equal to u square plus 2gs, or s. Oh, s is like s, no problem. Ut plus 1/2 gt square. By the way, in case of free falling object, the one other thing is like initial velocity is 0. Let's say you hold the object and you just let it drop. When the object starts dropping, the initial velocity is 0. So in all cases, u is 0 actually. So basically, this is 0. This should be 0. U is 0. That means this will give us v equal to gt, v square equal to 2gs, and s equal to 1/2 gt square. So these are the equation of motion for a free falling object. Yeah. So we are going to use this equation and that equations, okay, in today's class to solve the math. So let's start the math. Can you see the math here?
Yes, sir.
Fast math is the position of an object is given by along x-axis is given by 3t square minus 4t square plus t cube, where x is in meters and t is in seconds. Find the position of the object at the following time, like t equal to 1 second, 2 seconds, 3 seconds, 4 seconds. And this is the fast math. That means the position is given. The position as a function of time is given. You have to find out the position at different time. These are A, B, C, and D. Let's try it. It is very easy. At any point, if you find it difficult or if you cannot understand what I am saying or what I am telling, I am encouraging you and I am requesting you to ask me question or stop me. Okay. So now x equal to what? X equal to 3t plus plus minus 4t square plus t to the power 3. Minus 4t to the t square plus t to the power 3. This is the position as a function of time. And then I have to find out position at time t equal to 1 second. That means A is position at time t equal to 1 second. X of 1, that is equal to 3 into 1 minus 4 into 1 square plus 1 cube. That is equal to what? 4 plus 4 minus 4 plus 4, that is equal to 0. And then I have to find out x at time t equal to 2 seconds. 2 seconds is 3 into 2 minus 4 into 2 square plus 2 cube. It is equal to what? 16 minus 16, 8. And then 640, that should be equal to minus 2. And for C, I have to find out x for position for x equal time t equal to 3 seconds. That should be 3 into 3 minus 4 into 3 square plus 3 cube. So 9 and then 27, 9, 36, 27, 36. So this is the 0 again, right? Is it okay? Yes. Am I right or? And then yes, t equal to 4 second x4. This is really easy basically. 3 into 4 minus 4 into 4 square plus 4 cube. And this guy is basically equal to 64 minus or like say plus 12 minus 64. That is equal to 12, right? So that is equal to 12. So ABCD is done. Is clear? And then in part E, they are asking us, okay, what are the displacement? What is the displacement of the object between time t equal to 0 and t equal to 4 seconds? What is the displacement? Displacement between t equal to 0 and t equal to 4. So displacement is defined as delta x, and that is between t equal to 0 and t equal to 4. That means between the final position of x equal to 4 minus initial position x on 0. Right? 0 second. So what was the position at time t equal to 0? So we know x of 0 is 0, x of 0 is 0. So delta x equal to 12 minus 0. By the way, x of 0 is equal to 0. You can just replace t by 0 here, and this will give you x of 0 that is equal to 0. So delta x equal to 12 meter. Okay. And then part A, what is the average velocity for the time interval between 2 to 4 seconds? What is the average velocity for time interval between 2 to 4 seconds? So average velocity is like the average equal to delta x over delta t. So my delta x is time is 4 seconds and 2 seconds. So 4 minus 2 divided by and over x of 4 minus x of 2. So V average is basically equal to x of 4 equal to 12 and x of 2 equal to minus 2 and then 2. So that is 14 over 2, that is equal to 7 meter per second. So this is my average velocity. And G is graph. So G, I am asking you to graph it by yourself. Graph x versus t for time t is between 0 to 4 seconds. So x versus t graph for time, let me for you guys. X versus t graph for time t equal to 0 to 4 seconds. 1, 2, 3, 4. 1, 2, 3, 4. and then this is 0, and then -2, -1, -2, 2, 4, 6, 8, 10, 12. So 12 maybe something here. So at time t equal to 0, the velocity, this position was 0. At time x equal to 1, the position was 1. At time x equal to 2, the position was -2. And x equal to 3, the position was 0. And x time t equal to 4, the position was 12. So the graph should be like this. Something like this. This should be the position versus time graph. By the way, actually 12 should be somewhere here. 12 should be somewhere here actually. It should be 10 and this should be 12. This should be the position versus time graph. Now this is the easiest math for the class today. Let's try another one. I think you could see the slide. A different kind of math. If a particle's position is given by 4x equal to 4 minus 12t plus 3t squared, where t is in second and x is in meters, what is its velocity at time t equal to 1 second? Part A, they're asking me, so the math is like the position is given. The position is given as a function of time, like 4 minus 12t plus 3t squared plus 3t squared. This is the position of an object, okay? And in part A, they are asking me to find out the velocity of the object at time t equal to 1 second. So velocity is defined as what? d dt of x. That means d dt of 4 minus 12t plus 3t squared. So velocity is equal to 4. If we differentiate 4 with respect to time, there is 0. Minus 12t differentiation will give us minus 12. And for 3t squared, if I differentiate it, it is like 60. I think all of you know this kind of easy differentiation, right? Hello? Yes, sir. That's so easy, right? So now at t equal to 1 second, my velocity v of 1 is equal to, just we have to replace t by 1 minus 12 plus 6 into 1. So v of 1 is equal to minus 6 meter per second. Okay, this is part A. And in part B, is it moving in positive x direction or negative x direction? Whether the object is moving in positive x direction or negative x direction. Just then. Is the particle moving positive x direction or negative x direction just then? Just that means just at t equal to 1 second. At t equal to 1 second, whether the particle is moving in positive x direction or negative x direction. How to find it out? Can you tell me? Okay, let me try an example. Let me set an example. Let's say this is my time and this is my position. Okay, so my position. Here, the value of x is increasing here, 1, 2 in positive direction, 3, 4. And the value of x is negative in this way, that is minus 1, minus 2, minus 3, right? And let's say an object is going this way. This is a position versus time graph. So this object is going in positive x direction or negative x direction of this guy. So this guy is moving positive x direction. What about this one? Let's say, let me draw another one, the straight one. This is going along negative x direction. Okay, is it clear?
Yes, sir.
Okay. So this is negative x direction and this is positive x direction. Now, how to understand from this equation? From this equation, how I can figure out the object is moving positive x direction or negative x direction? The easiest thing is to take a slope. If we take a slope here, if I take a slope for this positive, this object, this line that is going in positive x direction, the slope will be positive or negative?
Positive.
Slope is positive. Now, what does the slope means? Slope means position versus slope by position versus time curve is velocity. Right? That means if an object is moving towards positive direction, positive x direction, in this case, its slope or velocity is positive. On the contrary, if an object is moving along negative x direction, in that case, its slope is negative, right? So velocity is negative. Is it clear? That means, so if an equation, if an equation of the position is given as a function of time to you, and no graph is given here, for example, just the equation is given here, by looking at the sign of the velocity or the slope, you can easily tell whether the object is moving along positive x direction or negative x direction. Now see, they are asking me to find out whether the object is moving at positive or negative x direction just then. That means at t equal to 1 second. So at t equal to 1 second, the velocity is negative. What does this mean? This means the object is moving along which direction?
Negative direction.
Negative x direction. Yes, the object is clear. Moving along negative x direction. And then our part C, in part C, there is what is the speed just then? What was the speed? What is the speed? Just then. Just then means what? 1 second. What is the speed at t equal to 1 second? What is the difference between velocity and speed? This is the velocity.
So velocity has direction, speed doesn't have direction.
So here this minus actually meaning direction. That is, it is going negative x direction. So speed does not contain any direction. It just have only magnitude. So you can say like, okay, speed is 6 meters per second. Clear? This magnitude. So velocity and speed are the same thing. At time t equal to 1 second, velocity and magnitude have the same magnitude. Velocity and speed would have the same magnitude, which is 6. Magnitude is 6. So that is the speed. Magnitude is the speed. Now part D. Is the speed increasing or decreasing just then? Speed ki increase kore or decrease kore? Since velocity is decreasing, so speed is also decreasing. Then E is like, is there ever instant when the velocity is 0? What does this mean? Is there ever an instant? That means, is there any time when the velocity was 0 or the velocity will be 0? If this is the position of a time, this is the position of a time, is there any time or is there any instant when the velocity will be 0? So how to figure it out? Velocity 0 means, that means I have to find out the time at which the velocity is 0. That means we have to find out the time, figure out the time t when v equal to 0. V equal to 0 means this is the equation for v. This is the equation for v, minus 12t, that implies minus 12t, minus 12 plus 16. Is equal to 0, or that means 60 equal to 12, or that means t equal to 2 seconds. So that means at time t equal to 2 seconds, the velocity is 0. Okay. So velocity is 0 at time t equal to 2 seconds. Clear? Is there a time after t equal to 3 seconds when the particle is moving in a negative x direction of x of x? Is there a time after t equal to 3 seconds? Achha, let me leave this math for you guys. This is a homework. Try this one at home. The part F. Is there a time after t equal to 3 seconds when the particle is moving in the negative x direction? That is after 3 seconds. 1, 2, 3 seconds. Is there any time when the particle is moving along negative x direction? You have to do this thing, okay? I left this for you guys. Let's try next math. I think this is easy math. At a certain time, a particle had a speed of 18 meters per second in a positive x direction, and 2.4 seconds later, its speed is 30 meters per second in the opposite direction. What is the average acceleration of the particle during this 2.4 second interval? Can you do it by yourself, guys? Can you try it, my dear students? At a certain a particle has a velocity of 18 meters per second. Let's say it's in along positive x direction at some time, and time t equal to 2.4 seconds later, the velocity its velocity at let's say its initial velocity, its final velocity is 30 meter per second along negative x direction. Let's say negative x direction. That means if I consider this as positive, this one should be negative. What should be the average acceleration of the particle during this 2.4 second interval? So the average acceleration is equal to delta v over delta t. Or I can say like final velocity minus initial velocity over delta t. Delta t is the time difference, and time difference is 2.4 second here. That is equal to 2.4 second. And VF is along negative x direction, is minus 30 minus 18. So a average is basically equal to minus 48 over 2.4. So it should be like minus 20 meter per second square. Is it clear? This is a very easy math. This is a very easy math. Guys, is it clear? Hello.
Yes, sir.
Yes, sir.
Let me try a different kind of math now. Here is the thing. A car is traveling at 56 kilometers per hour. Is 24 meters away from a barrier. When the driver slams on the brake, the car hits the barrier at 2 seconds later. This should be second. This should be second here. With the slam at 2 seconds later. What is the magnitude of the car's constant acceleration before the impact, and how fast the car traveling at the impact? Let's say there is a wall here, brick wall. This is a brick wall, whatever. Okay, and then this is a road. And there was a car here, let's say. This is a car. Okay. And this is a car here. And the distance between the car and the wall is 24 meters. When the distance between them is 24 meters, then the driver slammed the brake. And that is a constant deceleration. That means he is slamming a brake that is a deceleration. So let's say the acceleration is negative acceleration, acceleration is minus a, because she is applying brake, that is negative acceleration. And because of that, the car hit the wall after t equal to 2 seconds. The time t equal to 2 seconds. And the distance is equal to 24 meters. And the initial speed equal to 56 kilometers per hour. Can any of you convert it into meter per second, please? This is 56 into 1000 meter divided by 3600 second. Do you have a calculator? Any of you? So initial speed u equal to 56.
So 15.5.
6, right?
Yes, sir.
So this is the initial velocity. So that means a car was traveling initially at a speed of 15.56 meters per second, and when a constant acceleration of a is applying on it, negative acceleration, in 2 seconds the car travel distance of 24 meters. I have to find out the value of a. I have to find the value of a. So the value of a. So the formula that I have to use is s equal to, we know, s equal to, this is problem number a, we know s equal to ut minus half at square. So s equal to ut plus half at square. S is 24 meter equal to u 15.56 into 2 minus 1/2 a t square into 2 square. That means if I put it in this side, it should be like 4 by 2, that is 2a twice a equal to 31.12 minus 24, right? So this gives me twice a equal to what? 7.12, right? That means a equal to 7.12, that is 3.556 meter per second square. So this is the value of acceleration, or this is the value of negative acceleration that he is applying, that the driver is applying. And this part B, I want you to try part B. How fast the car was traveling at the impact? How fast the car was traveling at the impact? That means when the car hit the wall here, what was the velocity of the car then? Okay, at some point the car is gonna hit here after 2 seconds, after t equal to 2 seconds, what happened? The car is gonna hit the wall. So what is the velocity of the car when it hit the wall? Can you do it? Guys, can you do it? Is it possible?
Yes, sir.
Okay, then do it and write the answer in the chat box. Do it and write the answer in the chat box. Let me check what. Are you done or you are trying?
Sorry,
Okay.
gonna try.
Okay, just try. Give it a try.
I didn't see the question.
What, Elvis?
I didn't see the question. I lost the connection.
Okay. Give me a minute. Hello, Ishika. Hello, can you hear me, guys? Can you hear me? Hello.
Yes, sir.
So
Yes,
you are not done with the math? Are you guys trying? Or do you want me to try it?
Sir, the PowerPoint is off.
You need the PowerPoint to solve it? Okay. Yeah, the PowerPoint. Okay. All the information are given here. Let me do it then. Just let me do it. So what do you have to do? You have to find out the final velocity v after t equal to 2 seconds. So v equal to u minus at. So your a was like 15.56 minus is u minus at. A is 3.556 into time is 2. So your velocity after impact, or that right before the impact, is 15.56 minus this should be like 7.12. So your velocity would be 8.44
8.44.
meter per second. So the velocity at impact, during impact, the velocity of the object was or is 8.33 meters per second. Yeah. Let's try another math. This is a kind of lengthy or big math. Can you read it by yourself? A red car and a green car. So these are the two cars, one red car and one green car. They are identical except for the color. Identical car move toward each other in an adjacent line. They are moving toward each other. At time t equal to 0, the position of the red car was xr equal to 0. So this was 0. So this is 0. And the position of green car xg is like 220 meters. So that means the distance between them is 220 meters. Okay, it's clear. 220 meters. And then if the red car is traveling at a constant velocity of 220 kilometers per hour, the car passes each other at x equal to 44.95 meters. That means if the velocity is 20 kilometers per hour, then the car is gonna cross each other at 44.5 meters. That means here, let's say this is the 40.5 meter line. And if the red car travel at a speed of 40 kilometers per hour, in that case, both of them passes each other at a distance of 76.6 meters. Okay. So if the velocity is like 40 meters per hour, 20 kilometers per hour for red car, in that case, they crosses each other here. And if the red car is traveling at a speed of 40 kilometers per hour, then they crosses here at this point. So we have to find the initial velocity and constant acceleration of the green car. What do we have to find? We have to find out the constant velocity and acceleration of the green car. Is it clear? Is this math clear to you? We have to find the velocity and acceleration of the green car. So velocity of green car is equal to v, and acceleration of green car is equal to a. Okay, a and v are the acceleration and velocity of the green car. By the way, is this math clear to you guys? Hello, can you hear me?
Yes, sir.
Okay, is this math clear? Actually, hello.
Yes, sir. Clear, sir.
Yes, sir, it's clear.
So what I have to do, I have some information given here. So now the thing is, when the red car is traveling at 20 kilometers per hour. What is 20 kilometers per hour in meter per second? Can you convert it into meter per second? It's 20,000 divided by 3600. What should be the value? 200 by 36.
So 5.5.
5.56.
5.6 meter per second. When the red car is traveling at 6 meter per second, then it take 44.5 t equal to 44.5 divided by 5.6 second for the car, red car, to travel a distance of 44.5 meters. Right? Is it clear? Like, so 44.5 by 5.6 is what?
7.9.
7.9 seconds. That means in 7.9 seconds, the red car is traveling how far? 44.5 meters. And At the same time, so at 7.9 second, the green car is traveling how far? বলো কতটুকু distance travel করে? How far the green car is traveling? 220 minus 44.5. That is equal to what? Uh, 0.5.
175.5.
Hmm?
175.
175. Is it clear to you guys? So that means in 7.9 seconds, the red car is traveling 44.5 meter. And at the same time, because they are starting from the same time, at the same time they are starting. And at 7.5 seconds, 7.9 seconds, the red car is traveling 44.5 meter, and the green car is traveling 200 minus 44.5 meter. So that means we can say, distance, we can say 175.5 equal to velocity of the car ut plus 1/2 at square, that is basically equal to 7.90 plus 1/2 into a into 7.9 square. Is it clear, my dear student? Is it clear to you?
Yes, sir.
Yes,
Yes,
sir.
sir.
So that means 7.90 plus 7.9 square by 2 is what? 7.9 square divided by 2. Seven 7.9. Please tell me. I need a calculator.
31.201.
What?
31.201. 205.
Okay. Yeah. Is equal to 175.5. Okay. So this is, let's say this is 170. This should be like 175.5. 175.5. Okay. Let's say this is equation number 1. Now same again, but when the car is traveling at, when the red car is traveling at 40 kilometer per hour, this means what? 40,000 divided by 3600, that should be equal to what? Just double. 5.6, right? That is 11.2. 11.2 meter per second. Then it took t equal to 76.6 over 11.2. Can you divide these things? 76 by 11.2.
6.8.
So 6.83.
6.8. This is what I said, huh? 7 to travel. 76.6 meter. So at time t is 6.8 second, the car is traveling 76.6 meter, red car. And at the green car, at the same time, 6.8 second, at the same 6.8 second, the green car is traveling this distance, right? That is 200 minus 76.6. So at the same t equal to 6.8 second, the green car travel 220 minus 76.6, which is equal to what? 0.4, and then
143.
1,
130.
130.
So 143.4.
143.4 meter. So that means in this time the green car is traveling 43.4 meter. That is I can say that is 143.4 meter is equal to if I say VT, V is I don't know what is V, T is 6.8 T, V plus 1/2 AT square, A, and then T is 6.8 T whole square. So that means 143.4 equal to 6.8 V plus, what is 6.8 whole square by 2?
Twenty-three point one two.
93.1, right?
23.
23.1. So this should be like 23.1. So what I can say is like, so this is I can say like 23.1. Okay, so this is my equation number 2. So now I have two equations. One is this guy, and the other one is this one. So equation number 2 is 23.1a, right? So 6.8b plus 23.1a is equal to 143.4, and then this is my equation number 2, and my equation number 1 is 7.90 plus 31.28. 7.9 plus 32.1a is equal to 175.5. 175.5. So you see here, I get like two equations. So I get here two equations and having two unknown. So it is very easy to solve this math, right? Can you solve it for me, please? Or you want me to solve it? So let me keep it as a homework. So homework, and let me solve equation 1 and 2 and find the value of A and so this is very easy math. Just you have to do some substitution technique or other kind of thing. So I think you can do it, right? My dear student, can you do it?
Yes, sir.
Okay, yeah, you have to do it. And this A and B are basically the velocity of an acceleration of this spin curve, and I think you can do it. Just find the math. Now, 37. Number 37, they are saying is like figure 2.29 depicts the motion of a particle moving along. So this is a curve. This is showing the motion of a particle that is moving along x direction at a constant acceleration. So acceleration is constant, and this is the position versus time graph. And the figure's vertical scaling is set by xs equal to 6. So xs, this guy is 6, and this is 0. So this should be 2. And this should be 4, 2, 4, 6, and this should be -2. Okay, this is how the scaling is. We have to find out the magnitude and direction of the particle acceleration. What do we have to do? We have to find out the magnitude and direction of particles acceleration. So how to find the velocity acceleration? Can you tell me? So first thing first, let's say let's take these 2 points, 0 second and 1 second. So the velocity between 0 second to 1 second is v equal to time, difference in time 1 minus 0, and difference in position. At 0 second, the position was, oh, my bad. Velocity between 0 second to 1 second is velocity is difference in time, is difference in time by difference in position. So initial position was, initial time was 0 second and final time is 1 second. So 1 minus 0, and final position is 0, and initial position was minus 2. So 2 by 1, that is 2 meter per second. Is it clear? Hello?
Yes, sir.
Okay. And
Yes,
then
sir.
same again, and for the time between 1 to 2 seconds, for the time between 1 to 2 seconds, for the time between 1 to 2 seconds. Is the slide go? Right? Can you see the slide?
No, sir.
No, so okay. Let me wait. Okay. So what is the thing? Can you see it now? Hello.
Yes, sir.
Okay. So I think doing it this way will not take us anywhere. Let me do it in different way. Let's consider these 2 points, 0 second and 1 second. So the distance between these 2 points, x of 1 second minus x of 0 second, there's a displacement equal to ut plus 1/2 at square. So position at x equal to 1 second, at x equal to 1 second, the position was 0, minus x equal to 0 second, the position was minus 2, equal to u into t is 1 second, there's a difference in 1 second, plus 1/2 a into a square. So that means 2 equal to u plus a by 2. Okay, let's name it equation number 1. And again, consider these 2 points, 1 second and 2 seconds. So for t equal to 1 sec and t equal to 2 seconds, if I consider these 2 positions, then the distance traveled by the object or displacement x of 2 minus x of 1 equal to ut, or let's say x equal to 0, t equal to 0, between t equal to 0 second and t equal to 2 seconds. U is the initial speed from here, u into 2 ut plus 1/2 a t square. So x of 2 is equal to 6 minus x of 0 is minus 2 equal to u. U is the initial speed of the object and time is 2 seconds plus 1/2 a into 2 square. So that means 8 equal to 2u plus 2a. Right? 4 by 2, 2a. So this is the 2 equation. These are the 2 equation. This is equation number 2. And same again, by solving equation 1 and 2, you can easily find out the value of. You can easily find out the value of a. Can you do it, or you want me to do it? Let's say what 1 gives us. 1 gives us u equal to 2 minus a by 2 then substitute this into, we can write 8 equal to 2 into 2 minus a by 2 plus 2a. So that means 8 equal to 4 minus a plus 2a. So that means a equal to 4. Is it clear? Hello?
Yes, sir.
Did you guys get this math? Here, I let u is the initial velocity. I consider u as the initial velocity at time t equal to 0 second. At time t equal to 0, velocity u is the initial velocity. So the time is actually over. So I wanna stop here today. For today, I want to stop here. Maybe there are 1 or 2 more math that I am gonna solve tomorrow, and then we're gonna start a new chapter that is 2-dimensional motion tomorrow. So since it is 3, the time is up. So I wanna stop here today. Okay.